Okay. So Kenneth, as I was saying, is the lead developer of EasyBuild, and unfortunately he cannot make to CSCS physically, but we managed to arrange the remote presentation of EasyBuild, and we really appreciate his availability and also all his help and support with EasyBuild here at CSCS. So he cannot hear you guys during the talk. So if you have questions during the talk, you just tell us. We try to make it here at the mic, or you're going to write to him. So just to be aware that he's not hearing you in the back. So I think you can start. Thank you.
Thank you very much, Guillermo, for the introduction. I'm very happy to got the invitation. And I'm sorry I cannot make it to Lugano this time, but I'll make up for that another time. So the next about hour and a half, I'll introduce you to EasyBuild and specifically also how it can be used on Pit Daint, where it has been used for a while now at CSCS. The slides are available at the URL I mentioned here, but I can also send them to Guillermo or Theo for later. So very briefly first, I work at the HPCU Ghent team at Ghent University in Belgium. We're a central team for the whole university, so we help pretty much anyone in the university across all research domains in terms of high performance computing. We have a modest amount of infrastructure, it's certainly nothing compared to what CSCS has, but it causes enough trouble for us to keep us busy. We have over 3,000 user accounts, and our current team is 7 technical people and 1 manager. And we're also a member of the Flemish Supercomputing Centre, which is a collaboration between the Flemish universities in terms of high performance computing. A little bit more about myself. I got my training in computer science at Ghent University. And my PhD topic was working with machine learning, basically before it was cool. This is a long time ago. I joined the HPC team in 2010. And since then, I've mainly focused on user support and training, which includes the installation of scientific software. And as a part of that, I became the lead developer and release manager of EasyBuild. There's a whole bunch of things I like. There's some things I do not like as well. CMake is one of them, and I understand you got some training on that today. I won't go too much into details, but and I will be using CMake as an example in some of the demos I give today. So I certainly don't hate it, but so getting scientific software installed on HPC systems has been an issue for quite a long time, and all around the world, basically. So there's a couple of things that are quite specific to getting scientific software installed on HPC systems that make it hard. One part of that is that we prefer to compile the software from source, so we can properly target the architecture of the system, the processors, maybe even the interconnect and specialized libraries and so on. Also the fact that these HPC systems are used by many users at the same time, which have conflicting needs, makes it quite difficult to do this, at least in an efficient way. So support teams and also researchers who are using the systems are spending quite a lot of time, or I should say losing quite a lot of time in getting their software installed properly. And up until recently, there was little collaboration on this, even though many people were suffering from the same issue. So of course, there are lots of tools already out there that help you with getting software installed in general. The well-established one, of course, is the package managers in any Linux distribution, like Yum for installing RPMs, or IPT for installing software on Debian and Ubuntu and so on. And also on workstations, we have Homebrew for macOS and also Linux now, or other things like Portage and Package Source and so on. The big issue with most of these are not really prepared for scientific software in general, or for HPC systems specifically. They don't really have very good support for scientific software for a number of reasons, and a couple of things here are they don't know enough or don't care enough about things like MPI and BLAS and LAPACK GPUs. and don't really care about other compilers than GCC or more recently C-Lang. So Intel compilers or PGI compilers, they barely know about at all. They also are not a good fit for installing software on a multi-user system, like an HPC system, where they have many hundreds or maybe thousands of users who need different things working alongside each other. Even having just something fairly trivial, like having multiple versions of the same software package installed side by side, can already be a problem. And there's also a strong focus on generically optimized binaries, which is not what you want in an HPC context. More recently, there are tools like the Conda installation tool that's part of the Anaconda distribution, which is very popular for in scientific communities. There are a couple of issues here. So one of the problems is it's mainly targeted towards individual users, so it's not really a good tool to manage software centrally on HPC systems. And usually also get generically optimized binaries when you install software with CUDA, which is not, again, not what you want in HPC. And also we have found that once you install software with Conda, you're basically stuck to Conda. It's not that trivial to combine it with other tools, with installing software via other ways. So you're kind of locked in with Conda, and anything that's not supported in Conda is very difficult. And then also recently, there's the container hype that has also reached the HPC community, so Docker and Singularity and Shifter, things like this. In my experience there's a lack of attention for optimizing for the hardware you're going to run the software on. So they really focus on mobility of compute, so being able to build a container once and then move it along to wherever you're going to run the software, which kind of implies you're going to be using generically optimized or generically compiled software binaries, which goes against the performance part of the HPC. And also, Singularity claims that they have easy integration with system resources, like the interconnect for MPI or the GPUs that are in the systems. They claim it's a solved problem, but in practice, it's really not true. Especially with MPI, you have to be very, very careful on what you do to make it work correctly. And then it doesn't really solve any problem in terms of software installation, because somebody still has to create the container image you need or that you want to use. So if you're not able to do it yourself and you can't find anyone who creates the exact same thing that you need, then you're still stuck and you're not getting anywhere. So I have a feeling that for many of these tools, the performance part of high performance computing is the key issue, or certainly one of the issues. And I did some simple benchmarks recently to show my point. So here I was compiling the FFTW library and running a very simple benchmark on top of it. The yellow bar here was an FFTW built for Sandy Bridge and also running it on Sandy Bridge. And then the green bar next to it is running the same binary that was built for Sandy Bridge on a Haswell system. So you can see by buying a new system and moving your software there, you can get a 2x speed up. That's pretty good. But then when you dive a little bit deeper and you recompile the software specifically for this new system, you get another 60% speed up. So if you're not doing this recompilation, you're using a lot of performance. And this is basically what you get. You don't get this extra performance if you don't recompile the previously installed software. The downside here is this only works in one way. So if you build on Haswell, you cannot run it on Sandy Bridge. If it was fully optimized, you'll get these illegal instruction errors. And this is basically why many tools prefer building generically optimized binaries, because they then only have to compile it once for many architectures. So they're kind of sidestepping the performance problem to keep themselves sane, basically. Otherwise, they would have to build many different binaries, and it all becomes very difficult to manage. Basically, the same story here. So installing TensorFlow is pretty easy. You can just do pip install TensorFlow, and you will get a working TensorFlow installation. And this is a benchmark I did quite a long time ago. It was TensorFlow 1.4, so this is maybe 1.5 or even 2 years ago. But the point is still pretty much the same. If you do pip install TensorFlow, you get the red bar, so you get less than 1 image per second on this Intel Haswell. There were no GPUs here, so these numbers are quite low, but it helps to state my point. When we were building TensorFlow from source, we saw a 7x speed up just by building TensorFlow from source and properly optimizing it for Intel Haswell rather than using the generic binaries we got with pip install TensorFlow. So depending on how you install the software, you may be losing a lot of performance without actually realizing it too much. So then let's move on to EasyBuild. So EasyBuild is a framework for installing scientific software. And I'll explain more about what that means exactly. Whenever we get the possibility, we prefer building software from source rather than using pre-built binaries. There's a strong focus on Linux and HPC systems, and hence also on the performance of the installations we get. It kind of works on Mac OS, but not really. We don't actively test there, and you will quite soon run into problems unless you start doing a lot of extra work yourself. But for Linux and HPC, which include Cray systems, it works quite well. So by default, we will build from source and also optimize for the architecture of the host you're building on. And you can tell it to do differently if you want to. It's implemented in Python 2, and HPC again is still doing the lead development through myself, but by now it's a big community of people working together. You can find it on GitHub. It has a GPL v2 license. It's also on the PyPy website. We support many different compilers and MPI libraries, including the Cray programming environment since a couple of years. And there's a whole community around it today. So EasyBuild has been created about 10 years ago. It started internally in the summer of 2009. So sometime summer, it will be basically 10 years old. The first public release was in 2012. And since then, we've had many stable releases. So every 6 to 8 weeks, we have a new release with a bunch of minor enhancements and bug fixes. And here and there, also big new features. And we try keeping these frequent stable releases going as best as we can. In terms of supported software, the latest version of EasyBuild has built-in support for well over 1,700 different software packages, including fairly nasty stuff if you're building from source like TensorFlow and OpenFOAM, many of these chemistry packages or weather modeling software like WRF and so on. We also have quite a bit of bioinformatics software. That's because many sites who are using EasyBuild have a big user base of bioinformaticians. And then on top of these 1,700 packages, we also have many extensions. So I'll clarify later what extensions are, but it's basically things like Python packages, things like NumPy, SciPy, or R libraries that you include with your R installation, lots of Perl modules that you download and install from CPAN, and so on. So all of these things are kind of counted separately on top of the 1,700. We have a very wide support for different tool chains, a whole range of different compilers. Of course, GCC and Intel is there, CLang more recently. We have support for building software with PGI, even with IBM Excel. Well, that one isn't really widely used, but the basic support is there. And we have pretty good support for using the different Cray programming environments. There's actually one missing there, Cray PGI we have as well. And also it knows how to build on top of CUDA. And then a whole range of MPI libraries, including Cray MPI, and a whole range of math libraries, including the Cray libsci and F50W, MKL. All of that stuff is quite well known by EasyBuild. There's a couple of things in terms of terminology that I should clarify because I will be using these words or these terms in the rest of the presentation. When we talk about the EasyBuild framework, we really mean the core of EasyBuild, the heart of EasyBuild, which is a bunch of Python modules and packages that work together. and which provide a whole bunch of support for installing software in general. It has functionality for unpacking tarballs, for applying patch files, for running shell commands and checking the output and the exit code, for generating module files, and so on. So all of that is in the heart of EasyBuild and is agnostic to any particular software being installed. It's all written in a generic way. Then we have EasyBlocks. So each EasyBlock is a separate Python module, which you can sort of see as a build script. It's kind of like a plugin for the EasyBuild framework, and it defines the build and installation procedure of a specific software package, or a generic procedure, something like configure, make, install, or if you're using CMake, make, install, and so on. So we have separate EasyBlocks for those generic commonly used procedures. Then we have easyconfig files. We typically name them with a .eb extension. And these are basically just text files which specify to EasyBuild what to install. So it will specify the software name, software version, also which toolchain to use and which version of the toolchain, which dependencies to include and which versions of those dependencies, and so on. And we'll see a couple of examples of easyconfig files and how they look like. And then toolchains or compiler toolchains are basically a set of compilers, typically C, C++, and Fortran, together with a bunch of libraries, MPI, BLAS, LATEX, FFTW, and so on. And then extensions I already mentioned are additions to an existing Python installation or R installation, rather than a standalone software package. So what can EasyBuild do today? What does it have in terms of features? The main feature, of course, is fully autonomously building and installing software with a focus on scientific software. So you basically tell EasyBuild what to install, you hit enter, it goes and does the installation, and you can go out for coffee, and when you're back, hopefully it will be done installing the software for you. It will resolve all the dependencies first if they are not installed yet. So you can use the --robot command line option for that. And for each of the installations, it will also generate an environment module file. And I'll show in a bit what that looks like and where they are located. And the key issue here is that EasyBuild does not require admin rights to install software. By default, it will install things in your home directory, and you can tell it to install things differently or in a different location. As long as you have write permissions to where things should be installed, you're good. So even if you don't have admin rights on the system, you can definitely use EasyBuild to install your software. It will keep a detailed log of how the install procedure was done, so which commands were run, what the output was, which changes were made in the build environment, and so on. It keeps track of easyconfig files and patch files that were used, and also EasyBlocks, so you can reproduce an installation later, or maybe redo the installation on a different system the same way you've done it before. Has lots of configuration options, and I'll discuss several of them in a bit. And you can also extend it dynamically, so you can add additional EasyBlocks without having to reinstall EasyBuild or without having to change the EasyBuild installation. You can make it pick up easyconfig files from other locations, or you can even define your own tool chains that are not included with EasyBuild, and so on. So it's quite a dynamic setup. More features. So we have support for custom naming schemes for the modules it generates, including hierarchical modules. I won't really discuss what that is now, but basically any way you want to organize your environment modules, you can tell EasyBuild to do it in a particular way. We have 2 ways of exposing how EasyBuild does an installation, and I'll show you that in detail because that's quite important if you get started with EasyBuild, so you can get a good feeling of what it does underneath the covers, and when the installation is still running, where it's working on, and so on. We try very hard to test EasyBuild and keep it stable, certainly between releases. We have lots of unit tests, and before every release, we retest all the easyconfig files we include in the release to make sure that things are not broken. frequent releases I already mentioned. And as will become clear more towards the end of the presentation, EasyBuild today is certainly a collaboration between a whole bunch of HPC sites around the world. It also integrates with some other software services that you find typically in HPC context, Slurm Resource Manager, for example, or Singularity and Docker, and I'll show a little bit of that as well towards the end. Specifically, the integration with the great programming environment we have, and you can find more about that in the documentation. The link is posted there on the slide. Guilherme already briefly mentioned it, but the original implementation of what we have in terms of integration with the great PE was done back in 2015. And we declared it stable about 1 year later after a lot of feedback from CSCS and some minor changes left and right on top of the initial implementation. What we ended up with is basically a set of custom toolchains that are defined in EasyBuild. Basically one Cray toolchain for each of the programming environments provided by Cray. So we have a Cray GCC or Cray GNU, I think it is, a Cray Intel, a Cray PGI, and a Cray CCE for the Cray compilers. And underneath, this will basically take one of the programming environments and combine them with the Cray libsci and the Cray impage modules to define an EasyBuild toolchain. And together with this, we also have the opt-arch configuration option, which will tell EasyBuild which of the Cray PE modules to load. You can specify for which architecture the software is being compiled. And then we have support for providing a file that specifies metadata for the modules, the other modules that Cray provides, things like HDF5 or other optimized scientific libraries that Cray provides. EasyBuild can pick up on them rather than reinstalling this software. And underneath the covers, there's a whole bunch of trickery that we had to do when we touch or when we load and swap the Cray provided modules, because they're quite sensitive in terms of how they are being used. That was actually the trickiest part to get right, to get all of that logic right and make sure we don't end up with a broken environment. This has basically been used at CSCS for installing software on Pitsdaint and other Cray systems since 2015. So, and I haven't heard many complaints, and I'm quite sure it still works because I'll show some of the demos as well. Certainly actively used today on Pitsdaint. So, yeah, a bit more maybe before diving in to some demos. So one thing I want to clarify, first of all, what EasyBuild is not. So it's not a replacement for CMake, for example. So the things you're learning about CMake are certainly still relevant. What EasyBuild basically does, it wraps around the tools that are being used to install the software. So if you have a software package that's configured with CMake and then you build it with Make, install it with Make install, that's basically also what EasyBuild is going to do. It's just going to do it for you. You will be talking to EasyBuild, which then goes off and runs CMake for you and checks whether things have worked the way they should be. It also doesn't replace the traditional package manager, so we still require tools and libraries that are provided centrally in the operating system or on Cray systems that are provided via Cray modules, for example. Typical examples are glibc, so we do not build our own glibc, at least not yet, and that may change in the future. Security libraries like OpenSSL, we pick those up from the OS, or InfiniBand drivers. We don't install these things ourselves as well. So all of this is picked up from the OS, and on top we start building our own compilers and API libraries, and from that level on, it's all EasyBuild. And also EasyBuild is not a magic solution, certainly not for all your problems, not even for all your software installation problems. So when you try to install software with EasyBuild, you will still, or you may still hit compiler errors as well. So we try very hard to avoid that. And if we do hit errors that we can fix in a generic way, hopefully somebody has fixed them before you run into them, but it's certainly not a magic solution or a complete solution. And what EasyBuild is or can be, in my view, it's a uniform interface to install software or scientific software on HPC systems. So you're just talking to EasyBuild, whatever or however the software that you want to install should be installed. EasyBuild hopefully knows about it already, and you don't have to know, or you can forget about the specifics. So everything is automated. It has checks all over the place to make sure that things are done the way they should be done. And EasyBuild collects all that knowledge and automates all these annoying procedures for you. So by doing that, it saves you a lot of time. You just run an EasyBuild command, you hit the button, and you wait until the compiler is done compiling all the sources, and then hopefully everything will be in place the way you expect it. For HPC support team, it's a way to provide a consistent software stack to your users. So because everything is automated, it doesn't really matter who is doing the installation. The end result will, in terms of what is provided to the user, will always look the same. So we'll have consistent module naming or a consistent way of how the install directories are organized and so on. And since we are collaborating, since many sites are collaborating on EasyBuild, it has become an expert system for how software should be installed on HPC systems. So it has lots of small fixes, lots of small tweaks left and right, and combined everything together, you have a tool that really knows quite well how to install specific software. It can also be used by users, since it doesn't need any admin privileges to install software with. You can install it yourself, or you can use it yourself in your account on HPC systems to install anything that's missing or anything that you would like to install in a slightly different way. And it can also be used as a way to build properly optimized container images, and I'll show a little bit of that towards the end of the training. So maybe let's give the opportunity to ask questions. Any questions up until now? So somebody should give me a signal whether there are questions or not. For now, all right. So yeah, feel free to try and interrupt me if there are any questions. I'll try and pause a couple of times. So if you want to get started with EasyBuild, the first thing you should do is get it installed. So what does EasyBuild require? It currently requires a Linux system. So basically any Linux distribution should do. And you will need a Python 2.6 or 2.7 version installed so EasyBuild can find it. We don't support Python 3 yet in terms of running EasyBuild on top of it, but that will change soon. So hopefully in a month or two, you will be able to run EasyBuild on top of Python 3 as well. Next to this, we require an environment modules tool. So if you have the module command on the system, you're good to go. And to start off a compiler toolchain with EasyBuild, you need a system C++ compiler as well. It depends a bit on what toolchain you want to use, or something may already be pre-installed for you that you can leverage. To install EasyBuild, you can do a pip install EasyBuild. So it's a Python package like any other Python package. So you can use pip or one of the other 10,000 Python installation tools. So pick one, it should hopefully work. And because we don't want to rely on these sometimes broken or fiddly installation tools, we have our own Bootstrap script, which basically installs EasyBuild with EasyBuild. So we have a way of installing EasyBuild in a temporary directory first, and then using that installation to do the final EasyBuild installation. This is what we typically recommend, but if you know how pip works, then you can get away with that as well. On pip-daint, you don't actually have to install EasyBuild, it's already there. So when you load one of the Daint MC or Daint GPU modules together with the EasyBuild custom module, you're actually good to go. And this is also covered in the CSCS documentation behind this link. So if you follow what's behind this link, just load these two modules, you're actually good to go. And I'll show this in a bit how that works. Once you have an EasyBuild installation, a couple of weeks later, there will likely be a more recent version of EasyBuild that you may want to upgrade to. And we've made this as easy as possible. So first of all, we're currently, the latest version of EasyBuild is 3.9.0. We'll have a 3.9.1 out this week or maybe next week. But basically any 3.x version should be compatible with the previous 3.x version. So it should be a drop-in replacement. Nothing should break by updating to a new EasyBuild release. So we're quite careful there. We do have exceptions, of course. So the EasyBuild 4.0 release that we will do hopefully sometime in summer of this year, this will have some minor backwards incompatible changes, but they will be properly documented and there will be easy workarounds for them. The easiest way to update to a newer EasyBuild is to use EasyBuild itself. So you can do the install latest EB release command line option, you hit enter, and after a couple of seconds or half a minute, you will get a new EasyBuild module that you can load. So the box below shows how this is done on Daint, for example. And let me also show this hands-on. So let me try and switch to a terminal here. All right, so here I'm logged into Daint. And I have the Daint MC and the Daint EasyBuild custom module already loaded. So let me log in to start with a clean session like this. So to get started, you load Daint MC and the provided EasyBuild custom module, and this should give you a recent version of EasyBuild that is good to go. So this is installed somewhere on the /apps and so on. So this is not the very latest version. This is 3.8.1, which is the previous version. So we can try and install the latest version of EasyBuild using EasyBuild itself. So using the 3.8.1, we can try to install the 3.9.0. And let's see if this works. This shouldn't take too long. So EasyBuild has a way of checking what the most recent release is. So it's find the 3.9.0. And it's going to pick up this easy config file for EasyBuild and then install it. It shouldn't take too long. So what's going on behind the background is it's pulling in the sources from the internet for the different components of EasyBuild. It's installing these with basically Python setup by install for each of these components. And once these installations are done, it will do some sanity checking. So it will check whether things are the way they should be, whether the EB command is found for this new installation, whether some simple EasyBuild commands work as expected. And once that completes, you can see the new EasyBuild module 3.9.0. So the module is visible straight after doing the EasyBuild update because CSCS has pre-configured everything. And I'll show you what they have done exactly in case you want to change things. We can load this module on top of the other one. And now we are running EasyBuild 3.9. Whenever a new release comes up, you can just rerun the EasyBuild install latest EB release, get the latest version. Now note this version is installed in your home directory. Well, in this case, in my home directory. So of course, if the centrally provided EasyBuild version is there, you should probably prefer using that one. Okay, so the next part, once you've installed or maybe updated EasyBuild to the latest version, you should configure it a bit. We have quite a bit of configuration options here. By default, EasyBuild will install stuff in your home directory. I already mentioned this. And it will actually use the .local/EasyBuild directory for doing that. Now, this is not local as a hidden directory, so that's not very, very nice, but this is some kind of standard that we adhere to. But I definitely wouldn't recommend using this default setup. So you should configure EasyBuild to certainly install in a different location, and you may need to do additional configuration. The configuration can be done on 3 different levels. You can give EasyBuild a configuration file or even more than one. You can set environment variables to configure EasyBuild, or you can use command line options as well, maybe temporarily override a particular step. All of the configuration options we have work on all of these 3 levels. There are no exceptions. And as you would expect, the command line options override the environment. So if it's defined both on the command line and in the environment, the command line value will win. And then the same thing, the environment overrides the configuration files. And then a couple of easy ways to extend EasyBuild. You can give it additional easyconfig files. You specify the path to a directory with the robot path configuration option to make it pick up these additional easyconfig files. You can give it additional easy blocks or tool chains or your own custom module naming scheme via the dedicated include option it has. And all of this is well covered in the documentation as well. And again, EasyBuild is not only pre-installed on Pitstained, but also pre-configured. And I'll show you how it's configured and why it is configured that way in a bit. So we have an easy way of inspecting the current EasyBuild configuration because we have so many options. It's sometimes a bit hard to figure out, or certainly not fully transparent to figure it out what it's doing or how it's configured. So with the show config option, you can ask it how it's configured and then check whether things are where you expect it to be. Show config will only show a couple of important settings. It will always show these, and it will also show anything you have customized on top of the default. Anything that's different from the default configuration will show. And if you want to get the full list of configuration options, you can use show full config, but this will be quite long and big. So you probably don't want to always use this. The example output here shows you setting of one environment variable that specifies the prefix /tmp. We then specify a separate directory for the build path. So we use the diffs for this to get a fast build. And then we ask EasyBuild to dump the configuration. So we see that it's picking up the diffs here. And it's telling us this was specified on the command line. So the C is for command line. Most of the other options were specified on the environment. These are either the prefix setting here or the others are actually derived from the prefix setting. So they're also based on the environment. Except for the robot path option, this still has the default values. This is a default. And of course, if your configuration is more complex, things will get a bit more extensive here. So let's take a look at how it's configured on Daint. CSCS has pre-configured EasyBuild on Daint to work in a proper way. This output is a bit longer than what I showed on the slide. You can try running this command yourself to get this output. I've organized things a bit in the slides to make it easier to explain. So you basically get output like this when you run show config on Daint. And it has a couple of, well, CSCS really did a pretty good job of configuring it. Let's see what they did. So on the build directories that EasyBuild will use, where they were temporarily compile the software before it gets installed in the final location. For the run partition is being used. Same thing for the temporary directory, which certainly makes a lot of sense because these are both temporary directories being put in there. The installation prefix for where EasyBuild should install software is set to the EasyBuild directory and your home directory, a Daint subdirectory in there, and then another subdirectory, either Broadwell or Hadwell, depending on the architecture you are installing software for. So this depends on which exact Daint module was loaded. Whether you have Daint MC or Daint GPU loaded. And then also the sources that EasyBuild will download, or when it looks for sources, it will go and look into the sources directory of your home directory. So there's no point in putting this architecture-specific directory. It's a generic thing, of course. We'll always use the same sources, no matter for which architecture you are building for. And then next to this, we have a bunch of settings that are specific to Pitstained or certainly specific to a Cray system. So the first line I highlighted there, the external module metadata. This is a file that specifies to EasyBuild details of the Cray module that it can use, things like HTML5 or other libraries. It should not install, but it should use the ones provided by Cray. Because Cray still uses the traditional environment modules tool, the 3.2.10 version, rather than the LMOD, which EasyBuild expects by default. This is also configured here, so use the Pickle syntax for the module files and to use the traditional environment modules version, which is implemented partially in. And then also it specifies that software should be optimized for the Broadwell architecture, and this is derived from the Is it? Oh, okay. I can try. Did that started just now, or? Okay. No, it's a built-in microphone in the headphone, so I don't know. Is it still the same now, or now it's better? Okay. Well, if it happens again, let me know. Maybe it's the Wi-Fi acting up. I'm not sure. Okay. Yeah. So let's see if this is better. So where was I? Okay, the Broadwell, the OptArch setting here specifies to EasyBuild for which architecture it should compile the software. So this connects to one of the Cray PE modules that it will load. And then the other part of the custom configuration here, CSCS has configured EasyBuild to hide a whole bunch of dependencies and to hide the Cray toolchains. So the view you get in module OJL is not too much, let's say. Some things are there but are hidden from main view. And they also have some custom EasyBlocks that they are using to install software and some custom EasyConfig files that they list in this subdirectory and apps. So that's a whole bunch of configuration. Many of these things you don't really have to care about on paint. They will just work quite well, and I don't think you have to do a lot of custom configuration. Just load the EasyBuild custom module, and it should work quite well. So once you have EasyBuild installed and configured properly, you can start using it. The basic usage of EasyBuild, so you run the EB command and you specify to EasyBuild which software should be installed. And you do this typically by specifying the name of EasyConfig file. So in the first example here, I'm installing GCC 7.3 together with the particular version of Linutils 2.30. And I'm also installing a particular version of C. The version is a bit weird there. I'm installing CLang 7 with a GCC 7.3 and the Linutils 2.30. I'm installing CLang on top of GCC. If you just run the EasyConfig file, you hit enter, it will go ahead and try to do the installation. If all the dependencies are there. If the dependencies are not there, you may have to specify the robot option as well. So you're going to put down EasyBuild and take care of the installation, the dependencies first before doing the main installation. And to get an idea of which dependencies are missing, you can use the dry run option or the -D. So basically the output you will get when doing this, so here I'm asking EasyBuild to install a particular version of Tensorflow with a particular compiler and for a particular Python version. Once you hit enter, it will go ahead and do this. It will tell you what it's installing, and you may recognize this output. The output we got when updating to a newer EasyBuild is pretty much the same thing. So it will go through a whole series of steps: configuring, building, testing, installing, doing a sanity check, creating the module file, and so on. So the procedure is the same always. Installing software becomes pretty boring. Of course, in reality, installing Tensorflow will take a little bit longer. But yeah, that's the overall feeling. In the background, EasyBuild will do the installation stepwise. They will start by in the easyconfig file, figuring out where the source files are and whether it has to download them or not, or whether they are already available on the system. It will unpack the source file, maybe apply some patch files that are listed in the easyconfig file. Prepare the build environment, so defining things like $C flags or maybe custom environment variables. For Tensorflow, we have a lot of custom environment variables that have to be specified. Then it does a basic configuration. It will do the build step, which involves compiling the software. Maybe there's a separate make test step or something, which will be done as well. Once all of that worked, it will go ahead and do the actual installation. So it will copy out the binaries to the final installation directory, maybe using make install, or maybe just by actually copying files, depending on what the software provides. There may be extensions listed, additional Python packages or something like this to install. It will take care of that. It will do a sanity check to make sure that it will check for certain files and directories, maybe also run a couple of simple commands, like if you install Tensorflow, it will try a Python import Tensorflow, because that's supposed to work if Tensorflow was installed, and if not, then something's very wrong, and it will stop there and declare the installation as incomplete. If the sanity check passes, it will clean things up, so it will clean up the build directory, try to not leave things behind in a dirty state, and it will generate an environment module file for the installation. So all you have to do afterwards is do a module load, and you're good to go. And there's a couple of additional steps that may happen after that. The key thing here is this is the generic installation procedure that's baked into EasyBuild. And any of these steps can be customized, either through the easyconfig file. You can give custom configuration options or options for the install or the build command. Or if things are a bit more involved, as is the case with Tensorflow, you can customize these steps through an easy block, so through a Python module that defines the actions that should be taken during each of the steps. Yes, sure. No, I'm hearing you fine.
No, but the people are okay. Recording it. So my question was, the previous slide, my question is, you showed us an easy build of TensorFlow, and you're saying TensorFlow 1.13, FOSS 2018, Python 3.6. Now, supposing I just want TensorFlow, and I don't know what this FOSS is, and I don't really know which version of Python. Let's suppose I just want to. How do I find which numbers to put in all of that? Let's supposing I just pick some. If I pick some random project out of the cloud, like let's supposing I said HPX, and you had an easy build for it. How do I know which of all these numbers? Can't I just go easy build HPX, or do I have to supply all this extra stuff?
Right now, you have to supply something. You have to specifically tell it what to install. Let me show you here on Daint. It has a search option. I didn't mention this. And actually, it's actually case insensitive, so it doesn't care here. Let me do this to limit the output a bit. You will get similar output if you do it without the 1.13, of course. But here this is a long output. It has a short version as well, just capital S. But if you do a search based on software name, you will get a list of easyconfig files it knows about. So in this case, it would just copy this and go ahead and do the installation.
Could you just try searching? Oh, wrong microphone. Yeah. Could you just search for HPX for me? Capital H, capital P, capital X, and see what it says. HPX, all in capitals.
I'm not sure we have this one yet. Oh, maybe we do.
Okay.
Oh, okay. This is actually in the custom set of easyconfig files provided by CSCS.
Okay, so that's someone here.
Not EasyBuild itself, but somebody has provided easyconfig files for it. Yes.
So those are all 1.1, but different versions. That's Craig new.
There's a one.
Okay.
Yeah, there's. Yeah,
oh, and there's a 1.2. Okay, thanks. That's.
Yeah, these are different versions of the Craig toolchain, which means different versions of the programming environment. And let me show you as well. I have this open here somewhere. In the EasyBuild documentation, we have a list of supported software as well. So this is a more human readable format. If you want to check up front whether things are provided, you can go to this page. and it's organized alphabetically. So for TensorFlow, you can check which versions we support, for which Python version the EasyConfig file uses, and also which toolchain is used. So you can see with these three combined actually determine the name of the EasyConfig file. So this is what you're specifying to EasyBuild TensorFlow 1.13, built with the FOSS toolchain, this particular version, and then built for Python 3.6. Okay, very good question, thank you. Okay, now let me skip this part. Okay, so the stepwise installation procedure is the generic version is baked into EasyBuild, and you customize this depending on the software that is being installed. The customization may already be done for you in the background, either through an EasyBlock or through an EasyConfig file that you can just go ahead and quite easily update. Now, when you see the installation going, you just see configuring, building, installing, and it doesn't really tell you a lot. So very often you want to know what's going on in the background, either while it's doing it or upfront to get an idea of how things will be installed before actually go ahead and do it. We have two options for this. So we have the trace mode, let's say, where it will just provide you a bit more output while the installation is going. So it will tell you where the build directory is located, where the install prefix is, what source files it will use, whether there are any patch files that will be applied, which modules that will be loaded in the build environment, which commands are running, and you even get a pointer to the log file while the command is running, so you can check the output while the thing is still going. You will get information about how long each command run, and you will also get the result of the sanity check, so what it's actually checking for, outlined in a bit more detail. I did a version of this for TensorFlow. I trimmed the output a bit to focus on some key parts. So in the preparing step, which sets up the build environment, it will tell you which modules it's loading. So TensorFlow is installed with the Bazel tool, and it will use this particular version of Bazel, installed with this particular version of GCC. It will also load the Python module, of course, and a couple of other things that are needed to install TensorFlow. And then it will continue, and eventually it will run a Bazel command. It will use 6 cores to do the build of TensorFlow, and it will tell you the other options that were passed to the Bazel command and so on. So this can become quite a bit long, but at least it gives you an idea while the thing is running, what's actually going on in the background, and you can go ahead and tail this log file to see how far it is or whether it's actually still making progress and so on. Eventually, when it completes, it will tell you the exit code and also how long it took to do the build. Then this is during the installation process. So while it's running, you will get this additional output, and you can start spying on it if you want to. But maybe up front, you want to get an idea of how things will be installed using EasyBuild. Which commands will it run? Will it use Bazel, or will it use another way of installing TensorFlow, and so on. So this is actually a feature request that came from CSCS several years ago, and that was implemented because people kept asking for it all the time. At first, it seemed a bit difficult for us to get this working, but it turned out it was not that difficult at all once we started working on it. So the extended dry run option, or just EB-X for short, will show you how EasyBuild would install software without actually doing it. So it will spit out a long log of what would go on when you do the installation without the -X. So this will always run in a matter of seconds, no matter what you are installing. So if TensorFlow takes 1 hour to install, this thing will still run in a couple of seconds. It will just do a dry run of everything that's going on, running all commands, rolling all modules. It will not actually do it, but just pretend it would do it, and then give you an idea of how things would be done. You have to be a little bit careful in interpreting this, because it's not going to be 100% accurate. Because we don't do anything, you may be sidestepping some checks in the EasyBlock, where it goes ahead and checks the result of some output, the result of some command, and based on the output, it may make a decision to do one thing or another thing, or based on the presence of some file, it may fork fork off into a different direction. So you have to be a little bit careful, but in general, it's quite useful. And it's certainly very useful when making changes to EasyConfig files or changes to EasyBlocks to evaluate whether these changes are actually being picked up or not. So again, an example here of how this may look. This is for an old version of Wharf and an old Intel toolchain, but it's good enough to get the idea across. So this is a dry run. This will not actually do the installation, but it will tell you how it would be doing it. It will tell you which EasyConfig file it will pick up, which EasyBlock it will use, and where to find this EasyBlock so you can inspect the implementation, which module it will install, which source files it will use, and where it will download the source files in case they are not there. And then during the build step, it will tell you the different commands it will be running. So it will run the compile script 3 times, once for Wharf and once for the additional utilities that come with Wharf. And eventually, during the sanity check, it will check whether these particular files are actually installed. So real.exe, wharf.exe, these things should be there. Otherwise, the installation will be flagged as failed. And in the end, assuming the sanity check passes, it will spit out a module file as well, and it will show you the contents of the module file without actually writing it. So you get an idea of what's in the module file and how it may look like. Okay, now let's see this in action. Again, on PIDS-daint. What I did here, I created an EasyConfig file for CMake, the latest version, or at least a very recent version. Basically, all I did, let me show you how it looks like. All I did really was take an existing EasyConfig file for CMake and bump the version here and update this checksum for the sources. That's all I really did compared to the EasyConfig files you will find that are a part of the installation, of the EasyBuild installation. So what I want to do is I want to give this EasyConfig file to EasyBuild and run it with -x to show you the output it generates. So this, as you notice, it runs in 1 or 2 seconds, and this will just spit out a whole bunch of information of what EasyBuild would be doing. So let's take a look at it. So it will load, or it will tell you the list of loaded modules that it expects to have while building this version of CMake. It will tell you how it will configure CMake. So here you can see it will use OpenSSL and where it will be installed. Building is just running make minus J20. So it has detected there are 20 cores available. So it will try to use all 20, at least by default. Make install, nothing surprising here. And then during the sanity check, it will check for these things to be there. If any of these is not there, the installation will be assumed to be failing. Once that completes, it will consider these paths to generate the module file, and then the eventual module file may look like something like this. Now, this will have things that will not be there in reality, like if lib32 is not in the installation prefix, this will not be included in the module file. But it just assumes that everything is there and gives you an idea of what things could look like in the end. So now the installation didn't actually happen. We don't have this CMake 314 installed at all. But let's ask EasyBuild to do it, and let's give it a trace option to give us a bit more information about what's going on. So now it will go ahead and actually do the installation. And as you can see here, it gives more information about the commands it's running. So here it's running it's unpacking the source files, which is quite quick, as you would expect. Here it's running the configure command. And if we're quick enough, we can actually go ahead and tail this, assuming I'm landing on the same. I'm not sure which one I was logged into. Okay, well, anyway, if you log into the same daint login node, you could tail this and see the output of the configure command while it's still running. This will take a couple of minutes, so I'll just get back to it later, but trust me, this will finish and this will complete the installation and also give you some more details about the other steps that will follow. One thing, as I already mentioned, that EasyBuild does quite well is keep track of the different steps that were performed during the installation. So it keeps a detailed log file of how things were done. So you can go back later and inspect this log file and see what was going on. There's a lot of information in the log file, and depending on whether or not the debug option was enabled, you may get even more stuff. But the log file is organized quite well, so you have timestamps for each of the entries in there, and every entry provided by EasyBuild itself will start with a double equal sign and a space and then a date, so you can easily discriminate between output from EasyBuild or output from the commands it was running. So this is mostly useful if you want to go back and figure out why something is different in the installation compared to what you expected, or if a build fails, it will also have all the information there in the log file for you to debug. Then the easyconfig files that we showed for CMake, for example. So these are basically just text files that define a set of parameters, easyconfig parameters that are known by EasyBuild. And this way you tell EasyBuild what should be installed, which version, using which toolchain, and so on. Some of them are mandatory, as you may expect. We also require you to give a home page and a short description in every easyconfig file, so you don't only have the software name, but also some more metadata to figure out which package it actually is. And depending on what you're installing, you may typically get a list of source files, but we also have bundles of things where there are no source files. Typically have a list of dependencies or options to the configure command and so on. And the sanity check, if EasyBuild does not know how to check an installation, you should do it, you should specify how it should check on an installation in the easyconfig file as well. There's a long list of easyconfig parameters supported. EB-A will spit them out in a fairly organized way. And for specific easy blocks, like the Python package easy blocks, you may get additional parameters that only make sense when using this easy block. And you can get these as well when using the -E option and specifying the name of the easy block. So let's take a more detailed look at an easyconfig file. This is one for Wharf. Again, it's a pretty old one, but it doesn't really matter too much. So you specify the software name and version. You specify the metadata, the homepage, and the short description of the software. You give it the name and the version of the toolchain that EasyBuild should use to install the software. Also the sources and the patch files and where to download the sources in case they are missing. And then the list of dependencies. So there's a difference between build dependencies, which are only loaded while the installation is running, or runtime dependencies, which are also loaded as a part of the generated module file. And one thing to note here is that all these versions are fixed. So you have to specify a hard version for each of these. And the main reason for this is once this installation worked, you can easily give this easyconfig file to somebody else, or we can include it in the next version of EasyBuild and let other people install this particular version of Wharf quite easily. Some of these are specific to Wharf, so build type is something very specific to Wharf that only makes sense for Wharf. And we also define a version suffix, which is like a label you put on the module name, so we can tell which type of Wharf installation this is. One thing we are not specifying here is which easy block to use. That's because EasyBuild includes a custom easy block for Wharf itself. If there's no easy block specified, we'll go and look for an easy block for that specific. Yes.
So the idea that you have dependencies that are fixed there, so you've got netcdf, blah, blah, blah. Is there is it conceivable to say, well, I'm happy to take any version of netcdf from 4.3 up to, let's say, 4.6. It breaks with 4.7, but it's fine with 4.1 and blah, blah, blah. Can you do that?
Right now you cannot. It has come up before, and we haven't found a good way to do this without making it too easy to shoot yourself in the foot. There's a training about Spack tomorrow, and I will try to get back to Spack at the end. Spack does this very differently. What EasyBuild does is everything fixed. What Spack does is sort of, or certainly gives you a lot more flexibility. And in my view, the ideal situation would be somewhere in between. And I haven't really figured out yet how that would be done. So right now, all the versions are fixed in EasyBuild, both for the dependencies and for the toolchain.
Okay.
So this was an example, easy-config file. Whenever you do an installation with EasyBuild, there will be an easy-config file for it somewhere. Either you wrote it yourself, or it's part of the EasyBuild installation, or it is generated somehow by EasyBuild. So more details on this in the documentation, of course, and I'll give a couple of examples. I already gave an example with the CMake one. So when there are the easy-config files for the software you need already, you can use one of those and maybe just update it, bumping the version or changing the toolchain or changing some dependency versions if they are not what you want. We have very easy ways of making some simple changes to easy-config files, and I'll show an example of that. We have two different types of easy blocks. We have the generic easy blocks, which are just a generic installation procedure, something like CMake, make, install. Or we have a short list of software-specific easy blocks. Things like Wharf or Tensorflow have their own easy block, so you may have to pick one of those. For some things, like bumping the software version or changing the toolchain, we have an easy way of doing that without actually having to go and copy the easy-config file yourself. Try software version is a pretty straightforward one. You take an existing easy-config file and you tell EasyBuild to just use a different software version and try to install that instead. So the box below shows how I did this for CMake, for example. So it takes the existing CMake 3.12 easy-config and it tells EasyBuild, yeah, try to do it with 3.14.3 instead. And EasyBuild goes ahead and does it. So this is an easier way than copying the easy-config file and changing it according to what you want it to do. To show this in action, so here it completed the CMake we did before with the tracing output. To show this in action, we can do this for boost, so something a bit more involved. So we will take the boost 167 easy-config file using this version of the create toolchain. We will tell EasyBuild to do 170 instead. So basically all EasyBuild will do is read this easy-config file, change the version, drop the checksum that was there because the checksum is known to be tied to the version, and then we'll go ahead and try to do the 170 install instead. So you see it's picking up the 170 sources. It downloaded them because they may have been missing, and then goes ahead and does the installation using 170. So for some of these simple changes, you can use dedicated command line options to do this. We call them try because there's no guarantee that this will work. There may be something different in this new software version. It makes you do a little bit more work for it to actually be successful. There's a detailed documentation on writing easy-config files. So just to repeat a bit, so it's basically a set of values that you give for easy-config parameters. It's actually written in Python syntax, but it's not the code file. It's not executed as code. It's just evaluated, and then the values of the easy-config parameters are picked up. Some of them are strictly required, and others are commonly used, but not strictly needed. So if you know the ones here mentioned on the slide, or if you know what they are for, then you're good to cover 95% of the easy-config files you need. A couple of the common generic easy blocks that are there: configure, make, install. No surprise, we have a dedicated easy block for that. Same for using CMake and make, install. Now we have dedicated easy blocks for installing individual Python packages, either using setup.py or pip, or bundles of Python packages, which are under the covers, again, using the Python package easy block one by one. For lots of bioinformatics software, only has a make file and doesn't even have a make install target. So for this we have the make CP easy block, where you can skip the configuration step quite easily, just run make and then copy out some binaries and libraries. And then a bunch more easy blocks. The long list is mentioned in the documentation mentioned on top. And then for toolchains, we try to focus on specific toolchains a bit, just to focus the effort in the community. We have 2 toolchains that we call the common toolchains, which are the Intel compilers, MPI and MKL, and then the FOSS toolchain, which is everything open source, which is GCC, OpenAPI, OpenBLAS, and FFTW. And we do an update of these twice a year and try to motivate the community to focus on these versions. For Cray, it's a little bit different. So we have the dedicated toolchains that are maintained by CSCS, 1 per programming environment provided by Cray, and you should be using these certainly on Pitstein. And then one question that pops up on easyconfig files is, where is the balance between easyconfig files and easyblocks? So you can get away with quite a lot in easyconfig files. So without actually writing any Python code, you can do a lot of installations, because EasyBuild gives you a lot of flexibility in terms of specifying configuration options. We have a dedicated easyconfig parameter for that. You can tweak the build command. Depending on which EasyBlock you are using, you get more flexibility. So with the Python package EasyBlock, you can tell it to use pip rather than setup.py, or there's lots of options there. The line between easyconfig files and easyblocks is not really clear. So sometimes you can use a generic easyblock in, let's say, a creative way, and you can get away with creating a fat easyconfig file and to make things work. In the central repositories, we're a bit careful there. Whenever an easyconfig file becomes too dirty or too big, we try to move the logic that is needed to make it work into an easy block, so into a Python module, implement it once, and then forget about all the specifics and just letting the logic in the easy block handle it. There's a couple of reasons why you may prefer an easy block over an easy config file. For some people, this is a bit of a leap, because implementing an easy block really requires some Python knowledge to make it work properly. And ideally also some knowledge about what the EasyBuild framework provides and what you can leverage in an easy block. While in an easy config file, it's more straightforward to get things to work the way you want it to. And again, there's extensive documentation on implementing easy blocks and the things you can or you can do there and how to do them. So something I wanted to do here, again with CMake as an example, I have a small CMake project prepared here. So it's just a hello world program with a very simple CMake lists, which will compile this hello executable and install it into a bin directory. What I wanted to do is show you how to write an easy config file for this. What we're basically aiming for is that we can do this. We can do an EB hello, it will go and do the whole installation, and we end up with a module, let's say, compiled with the Cray GNU toolchain. So we start with a blank file. First thing we do is we tell it to use the CMake make easy block, since we'll be using CMake. The name of the project is hello. The version is 1.0. We'll have to give it a home page, but we'll just give it an empty string here. And same for the description. Doesn't matter too much. There's one thing I forgot, is to create the source tarball. So I just have a directory here. I'll pack this up into a tarball, and I'll put it in the source directory for EasyBuild, where it will go ahead and look for the sources for this package. So, and I should use hello in the capital H to make sure it finds it. Then the list of sources is just the hello. And here we'll use a template to avoid hard coding the version. So EasyBuild will replace this by the value of the version easyconfig parameter. We'll need CMake as a build dependency. So this in the build dependencies, we'll use the 3.12 provided by CSCS. And here, I'll explain this in a bit. This is basically telling EasyBuild, pick up the CMake module that was built without a specific toolchain, so with the generic toolchain. The toolchain we haven't specified either yet, so we tell it to use GNU, the particular version of Cray GNU. And here, of course, I'm writing an easyconfig file from scratch, which is not what you would typically do. You would use an existing one if it's there already, or use something that's very similar to what you need. We'll tell it to check for bin hello in the sanity check and no directories. And let's give it a module class as well to keep things clean. So unless I missed something, this should be good. Let's give it a shot. No, this one. And of course, I mistyped the sources. Oh yeah, I gave it hello CMake. Like this. It was telling me it trying to find the sources. The installation failed because I could not find the source file, because here I gave it the name hello CMake. Let's try this again. There it goes. It's telling me it's installing this module file, and the name of the module file is based on the software version and the toolchain being used. It will run the configuration, which takes, even though it's a toy project, this will take a couple of seconds. I should have used --trace to show you what, well, let me start it again with --trace to show what's actually going on. So during the configure step, it's running CMake, of course. And EasyBuild knows how to tell CMake where the software should be installed. So it's creating a separate directory for this particular version of hello. And it also knows when the Cray GNU toolchain is used, how it should configure the installation. So the specific, let me scroll back, the specific compiler commands to use, for example, for C++ software, by default, it will also give specific optimization options and so on. And here somewhere, okay, I don't see it mentioned. But eventually the installation completes and you get a module for the hello software. And as a part of the sanity check, it will have checked for the bin hello, so we can run this by just loading the module and running hello. So this is a very short and quick demo of how to create an easyconfig file from source, which could look something like this. Here I did something extra. I also gave it a sanity check command to run. So before generating the module, it will actually set up the environment, try to run the hello command, and only if that worked, it will be happy and actually generate the module file. Then almost wrapping up here, once you have easyconfig files, or if you're making some changes to make EasyBuild better, of course, be very happy if you contribute them back, or any form of feedback, bug reports, or joining discussions on the mailing list or on the Slack channel is certainly welcome. If you do have easyconfig files, specifically updates to software, updates to things we already have, or maybe additions, new software we do not have supported yet, we'll be very happy if you contribute them back as well. This involves creating a pull request to our GitHub repository, our easyconfig GitHub repository. And because this is a common thing that pops up, we have done some extra work to make this very easy for people to contribute back. What we've done is we've added dedicated command line options like new PR and update PR, so you can make contributions straight from the EasyBuild command line. So you don't even have to know any Git or be very familiar with GitHub to be able to make contributions. So this is how you would typically, or the generic way of contributing something would be massaging things, putting things in the right place, renaming easyconfig files specifically for EasyBuild, creating a branch, staging the easyconfig file, doing a git commit, a git push, and then log into GitHub and click around a bit until you have a pull request opened. With the EB new PR option, this is all condensed into a single EasyBuild command. And there's also no stuff left behind. So you don't even have a local branch created on your laptop. It just gets pushed to EasyBuild, and then the pull request is opened fully automatically. So this is a big time saver, both for people not very familiar with Git or GitHub, and even for experienced developers. This saves quite a bit of time. The EasyBuild community, so a little bit less about the technical part. So eventually a community grew around EasyBuild over the years. It's hard to assess how many sites are using it, but it must be in the hundreds. And also several companies are using it. CSCS has been using it for quite a while. You have an active mailing list, an active Slack channel, and we're also on IRC. So the people on IRC can talk to the people on Slack. So it's up to you which technology you use. We have 12 active maintainers that help with keeping EasyBuild stable and dealing with incoming contributions. So most of these people are working with the European HPC side, but we have Miguel in Singapore and Bart in Canada as well, together with Davide in Vanderbilt University in the US. So it's really a worldwide project. And then we have many more contributors. These are just the maintainers who help out with processing the incoming contributions. We tried to get an idea of how well EasyBuild is used, which is quite hard. The best way I found is looking at the visits to the documentation. So hopefully the people actively using EasyBuild visit the documentation once in a while. We see this is growing. So right now we're over 500 weekly visitors at the documentation. And we can also check where they are coming from. And then we see more or less the expected sites where you would expect lots of HPC activity. We see lots of EasyBuild usage as well. In terms of contributors, so we have three main separate repositories, one for the EasyBuild framework, a separate one for the EasyBlocks, and then a more active one for the EasyConfig files, where we get over 1,500 pull requests each year. Today, we have over 200 unique contributors for EasyConfig files and over 100 for EasyBlocks, and a little bit less for framework. So of course, the deeper you go into EasyBuild, the more difficult it is to make contributions. And in terms of unique contributors per year, we see this growing as well, certainly for EasyConfig files. So we hope to reach 100 unique contributors this year in 2019. And then very briefly, we have some integration with Docker and Singularity as well. So you can use EasyBuild to install software in a container image. So rather than writing a recipe to build a container image, you can use EasyBuild inside that recipe. And EasyBuild actually has support for generating these recipes. So rather than letting you write them from scratch, EasyBuild can generate them for you. So we have a containerize option, which basically just generates a recipe file either for Docker or Singularity. And inside this recipe, again, uses EasyBuild to install the software in the container image. And you can even ask EasyBuild to go ahead and do the actual build of the image itself, which then makes it call out to either sudo Singularity build or sudo Docker build. So to build the container image, you do need admin rights. And what we have today in terms of integration is a bit experimental. So we know it has some rough edges and things we're not happy with. And we hope to improve on this in the coming weeks and months. So what does it look like? Let me show this interactively. Also on Daint. So first thing I will do is I will define which base container it should be used in the recipe. This is one that's being pulled from Singularity Hub. And then using the containerize option, in this case, I will ask it to spit out a recipe to install TensorFlow in a container, in a Singularity container in this case. And I have to give it the experimental option because any experimental feature in EasyBuild requires this flag, so you at least know it's not fully stable yet. This will run really quickly. It gives a warning about loaded modules, but that's not a big issue. This will run in seconds because all it really does is in our installation prefix as a container subdirectory, all it really did is generate this file, which is a recipe for building a Singularity container image. It will specify the base image to use and where to pull it from. And here it has some logic to make sure that EasyBuild has the most recent version, it will switch to an EasyBuild user, which is prepared here in the base image, and then it will run an EasyBuild command to install TensorFlow in this container image. So you can give this recipe to Singularity Build, and in the end, you should end up with an image that contains TensorFlow. And then it does some more things. It preloads the module that EasyBuild has installed to make sure if you run the container, you actually have TensorFlow ready to go. So we can certainly improve this a lot, but it's a starting point at least. A whole bunch of features that were not discussed here in detail. I don't have the time to go through them, unfortunately, but you can find more about all these things in the documentation. And then two more things very shortly. We're working on EasyBuild 4.0, which we hope to release by summer 2019, so we're getting quite close. The main reason to do a major version bump of EasyBuild is because we will have support for running EasyBuild on top of Python 3. So we finally got around to taking care of that. And we're making some other changes along the way, which would require the major version bump. So we have learned the hard way that having several dependencies, required dependencies, makes things a bit difficult in terms of getting started with EasyBuild. So we made sure to clean that up. So right now, or at least in EasyBuild 4, there will be no more required dependencies. So everything you need to run EasyBuild will be included with EasyBuild itself. We're renaming the dummy toolchain to something more sensible. That's a fairly minor change, but it's a bit intrusive. So it's a breaking change. So that's why we include it here. And some more things that we hope to tackle, also things that have been annoying for some people in the community. Hopefully, we also get around to making the integration we have with Singularity and Docker fully stable, and hopefully it will be picked up by people as well. So this is happening in the coming weeks and months. And two of these things are already done in the 4.x branches we have in the repositories. The others are still being worked on, but are close to being finished. And then one more thing, a little bit of preparation for the Spack training or the Spack talk tomorrow. So one of the questions that pops up a lot is how EasyBuild compares with Spack. So Spack actually turned up a couple of years after EasyBuild was first released. And it takes a different approach in a number of things. So first of all, the licensing is different. EasyBuild is GPL, while Spack is using MIT Apache dual licensing. Today, there's no stable release yet for Spack, so there's no 1.0 yet. We're still working on things and sometimes making some breaking changes, which in my view makes it sometimes a bit difficult to pick up on, or sometimes a bit annoying, especially when updating Spack. While EasyBuild has been stable since 2012, so we do a lot of work, do a lot of testing, keep it very stable. And whenever we make a backwards incompatible change, it will be very clear in the documentation and in the release notes, and also in the version number. In terms of supported software, it's more or less equivalent. There's different software supported in EasyBuild and Spack, so it's certainly not a full overlap. But in terms of raw count, they're pretty much on the same level. In my view, EasyBuild is a little bit more targeted towards HPC user support teams and maybe end users that just want to install existing software, while Spack is more targeted towards developers of big scientific packages and giving them lots of flexibility to juggle dependencies and different compilers and so on. So the focus there is a bit different, which also means that it still makes sense that both projects exist side by side. They solve similar problems, but in a very different way. As I already mentioned, the versions and the dependencies in EasyBuild certainly today are fixed, while in Spack you get a lot of flexibility and maybe a bit too much. So in my view, the optimal way is somewhere in the middle, and maybe at some point we will get there. EasyBuild does not work on top of Python 3 yet, but that will be fixed in the coming weeks. And we have little support for macOS, basically. The good thing is both of these projects have an active community, very supportive community, and Todd Gamblin and I are also frequently discussing things. So it's not like these projects are fighting, we're actually working together, or certainly discussing things and sharing news with each other. There's a more detailed comparison about EasyBuild and Spack and also Conda and some other tools in this talk I gave at FOSDEM last year. And then, so if people want to read papers on EasyBuild, they can. There's a couple of them. There's one more that I know of coming up quite soon. So you can dive into some of the history or some of the main features that have been implemented in EasyBuild. And that's what I have.
Any questions from you guys?
Add much. Yes, that's certainly possible. So yeah, I heard the question. Let me show you in the documentation. In the writing easy config files part, we have to look a bit, but we have a section on source files. And if you scroll down a little bit, there's an alternate way of specifying source files. Let me find it here, which has a separate one downloading from a Git repository. So what you can do is you can specify the source files in a slightly different way. Like this, git config, this is the key thing here. Give the URL of the Git repository, you give the commit ID or version or tag or whatever you want. Maybe you want to do a Git clone recursively because it has sub-modules. And then here, this is a name for the for the tarball that EasyBuild should create based on this. So what it will do, if it doesn't find the source tarball that's named like this, it will go and do the git clone, git checkout, whatever it needs to do, create this tarball and puts it in the source directory. So it doesn't have to redo the clone later for this same file name. You can certainly do it. I mean, you can script around EasyBuild. You can use EasyBuild as a Python library and basically generate different easy config files and then pass them all to EasyBuild and make it go with all of them. And if you do this, yeah, we don't have very good documentation on this yet, but it's there. So you have to. There's one key thing you have to do. You have to set up the configuration. So you have to call a particular function first to make EasyBuild happy in terms of its configuration. So it picks up all the environment variables and configuration files. But once you've done that, you can basically call out to any functionality in the EasyBuild framework from within Python. Yes, basically, if you're careful enough. So you would have to make sure that each of these versions somehow gets a different module name. Yes, but you can use a version suffix to give it different labels, or yeah, you can certainly do it.
Well, in that case, thank you very much from all of us. And it was lovely of you to join us remotely, and it seemed to work very well. So well done to you guys. At the
I agree.
Thanks to you. I'll say goodbye to you then, and you can.
Yeah, thank you very much.
Thank you.
Bye-bye, everyone.